Okay, Assalamualaikum. A water solution entering the propeller in the pump is producing thrust force Ft, which is depending on the density rho, diameter d, the rotational speed omega, and the fluid velocity v. By taking rho, d, and omega as repeating variables, prove that Ft over rho omega square d to the power of 4 is a function of v over omega d. What you need to do first, you have to list all parameters. So we have thrust force is a function of density, diameter, rotational speed, and velocity. So next, you have to come out with each of these unit. Okay, Ft is a thrust force. Unit of thrust force is kilogram per second square m. And then when we convert to the primary dimension, we have m L over t square. M is represent for mass, L is for length, and T is for time. Next is rho. Rho is kilogram per meter cube. So the primary dimension for rho is mass over L to the power of 3. Okay, next is diameter. The unit for diameter is meter, and the primary dimension for diameter is L. And then omega. Omega is a rotational speed. The unit for omega is 1 over second. And then primary dimension is 1 over t. Next is velocity. The unit for velocity is meter per second. And then the primary dimension is length over time. So we have list all the units with the primary dimensions. Next, what we are going to do is to find number of n. N is represent how many parameters in our question, in our solution. So we have 1 for Ft, second is density, third is diameter, fourth is rotational speed, and then fifth is velocity. Therefore, n is equal to 5. Next, we have to determine K value by using equation K is equal to n minus J. So what is J? We already know about n, but we still not been introduced about J. So J is the number of primary dimension. So we have three primary dimensions that has been used, which are M, L, and T. Let's take a look at our unit here. So we have M, L, and T. So the number of J for our question is 3. So the value of J minimum is 1 and the maximum is 3. So we substitute into the equation. K, n is 5 minus 3, we have 2. So if we already get the value for K, what does it mean? This represents the number of pi's. So if we have the number of value of K is equal to 2, we have 2 pi's. Okay. Then number 3, we have to put into equation for pi's. So we have 2 pi's. So pi 1 is a function of pi 2. So this is the equation that we can use throughout the question. Not necessarily use, but we have to find this dimensionless equation. So fourth, we have to determine repeating variables. So in this case, we already been given with repeating variables rho, d, and omega. So in this case, we already been given rho, d, and omega. But what if we do not been introduced with these repeating variables? How can we choose repeating variables? So there is a guidelines for choosing repeating parameters. So this is the guideline. So what is the guidelines? Okay, first, never pick dependent variable. Never pick dependent variables. What does it mean? So let's take a look our question. So we have ft equal to, or is a function of density, diameter, rotational speed, and velocity. So here, which one is dependent variables? Of course, ft is a dependent variables. Oops, sorry. Why ft is a dependent variables? Because value for rt depends on the value for density, diameter, rotational speed, and velocity. So that is why ft is a dependent variables. So next, chosen repeating parameters must represent all the primary dimension. Chosen repeating variables must represent all primary dimension. Is it necessarily if we choose one parameters must represent all primary dimensions, or we have to make a multiplication repeating variables to repeating variables? So let's take a look at your question. Okay, chosen repeating variables must represent all primary dimensions. So your primary dimension is the number of your primary dimension is 3, and then the number of repeating variables is the same as the values for j. If there is 3 primary dimension, your repeating variables is 3 repeating variables. If you have 2, then you will select 2 out of 5 parameters here. So now we have to select 3 repeating variables. So ft is excluded from our repeating variables because the point number 1 say that never pick the dependent variables. Then we have to move to the next parameter, rho, diameter, omega, and velocity. So let's take a look. If we combine density, diameter, and omega, what will happen to the unit? Okay, we choose rho, kilogram per meter cube, and then diameter is meter, and then omega is 1/t. So we make multiplication rho, d, and omega. So we multiplied rho times with d times with omega. What will happen? ml over to the power of 3 times with L and times with 1/t. So we have to cancel out, and this will be 2. So the unit is ml/t. So this is what point number 2 is all about. So chosen repeating variables must represent all primary dimension. It does not necessarily one parameters represent all primary dimension. So can we select other variables, repeating variables? We don't want to select density, diameter, and omega. We want to select density, diameter, and velocity. So what will happen? So velocity unit, the primary dimension is L/t. So we multiply rho, d, and v. So rho is m/L to the power of 3 times with L times with L/t. So we can cancel out, then the unit is m LT. Then it can be used repeating variables rho, d, and velocity. Density, diameter, and velocity. So both of it can be used. Okay, we move to the next point, number 3. A combination of the repeating variables must not form a dimensionless group. Combination of repeating variables must not form dimensionless group. So which means if you multiply rho, d, and v, if it's get 1, which is no units, then that is what we call as a dimensionless group. So if we are select combination of repeating variables which come out with a dimensionless group, then it is impossible to generate the values for pi's. Okay. Next, number 4 is never pick parameters that are already dimensionless. Okay, never pick parameters that are already dimensionless. Okay, the reason why we meet or why we do Buckingham PI Theorem is to create a dimensionless group. But if you are selecting a dimensionless parameter, then there is no point for you to proceed with the Buckingham PI Theorem. Therefore, that is why point number 4 mentioned that never pick parameters that are already dimensionless. So let's move to point number 5. Never pick two parameters with the same dimensions or with dimensions that differ by only an exponent. Never pick two parameters with the same dimension. Or with dimensions that differ by only an exponent. By only an exponent. So for example, you already select length, and then you want to select another parameters which is length. So this is what point number 5 said, that you never pick two parameters with the same dimension. Or you select parameters number 1, dimension L, and then you select parameters number 2 is L square. Then there is no point for you to select for the same dimension, because L and L have the same dimensions. The difference is only by an exponent. Okay, and then Number 6, pick common parameters. Okay. Since they may appear in each of the pies. And the last point is pick simple parameter. So do not pick complex parameters because it will make your calculation a bit harder. Therefore, it is better for you to pick simple parameters. So that is guidelines for choosing repeating parameters. Okay, but in this question we already been given with the repeating variables rho, d and omega. Okay, remember that this number of repeating variables is equal to number of j. What I mean is, if j is 3, then your repeating variables must be 3. Number of repeating variables. If your j is 2, then your repeating variables is 2. The minimum number of j is 1 and the maximum number of j is 3. Okay, so what's next? Okay, number 4, 5. Okay, this is number 5. So we will proceed to determine the pi 1. Okay, where is pi 1? From this, okay, we already use rho, d and omega as our repeating variables. So ft is our pi 1 and velocity is our pi 2. So pi 1 is ft. So pi 1 equal to ft, and then you put the first repeating parameters, which is rho to the power of a, and then diameter to the power of b, and last one is omega to the power of c. A, B, C. It doesn't matter what letters that you will put for repeating variables power, as long as you can differentiate between A, B and C. Okay, then we substitute. You need a dimension for all of these parameters. Okay, ft, m, l, t minus 2. Okay, and then rho is m, l minus 3 a, and then diameter is l power of b, and then last is omega t minus correct, t minus 1 c equal to m to the power of 0, l to the power of 0, and t to the power of 0. But please do not add some more parameters, some more dimension p, because this is dangerous. Why? It can be explode. Okay, we have to segregate between M, L and T. So first we determine for M. Okay, M to the power of 1. So we put 1, this 1, and then M to the power of 1 times with A. So it will be plus A. And then for this there is no M, and for C there is no M. And then it's equal to 0. A is equal to minus 1. Then we find for L. So L to the power of 1. So 1, for this L to the power of minus 3 times with A. Minus 3 times A is minus 3A. Then L to the power of 1 times with B is plus B. And then this one, there is no L. Therefore, is equal to L equal to 0. Now substitute the value for A to this equation. 1 minus 3 minus 1 plus B equal to 0. So 1 plus 3 plus B equal to 0. So B is equal to minus 4. And last is T. Okay, T negative 2. So negative 2, and then there is no T here. Same with here, and here is T to the power of minus 1 times with C is minus C, and equal to 0. C is 2 minus C is equal to 2. C is equal to minus 2. Then substitute value for A, B and C into this equation. So pi 1 equal to Ft. So rho to the power of minus 1. So the diameter to the power of minus 4. And then omega is to the power of minus 2. So your pi 1 would be Ft over rho d to the power of 4 omega square. So let's take a look at our question. So we already solved for this section, left hand side. And then to make sure that our steps is correct, this value, this unit will be dimensionless. This is to check whether our steps is correct or not. So let's take a look at this. So Ft is M L T minus 2 over rho is M L minus 3, D is L power of 4, and then omega is T minus 1, 2. Okay, this is for checking purposes. So ml to the power of 4 will be ml t minus 2. Negative 1 times with 2, negative 2. So we can cancel out this, then it will equal to 1, which is dimensionless. Okay, so that is for pi 1. Let's move to the pi 2. Okay, pi 2 equal to velocity, right? So we take a look at this. So velocity is our pi 2. Then velocity and dimensionless, no, I'm sorry, repeating variables, rho a d b omega c. So this is the reason why these parameters is called repeating variables, because for every pi's that we do, these parameters will be there to assist you to get dimensionless group. So pi 2. So what is the unit for velocity? L t minus 1 meter per second. And then m l minus 3 power of a, and then diameter is L to the power of b, and then omega is t minus 1 to the power of c equal to m0 L0 t0. So m, this type is the same. We segregate m, l and t. So m, here there is no m, here only one m to the power of 1 times with a. Then here no m, here no m, then equal to 0. So a is 0. Then l, so here 1. Okay, and then L is minus 3 times with A, and we get minus 3A. Okay, here 1 times with B, then we get plus B. Here there is no L, and then equal to 0. Substitute the value for A into this equation. 1 minus 3 times 0 plus b equal to 0. B is equal to minus 1. And then t, so here there is 1t minus 1, and then for second no t, and then for diameter no t, and then there is 1t here, minus 1, minus 1 times with c, then we will get minus c equal to 0. Minus c 1, c is equal to minus 1. So substitute all the values inside this equation. So pi 2 equal to v rho power of 0 d to the power of minus 1 omega to the power of minus 1. So we have v over d omega. So rho to the power of 0 is equal to 1. Then our pi 2 is v over d omega. Then lastly, substitute into pi 1 equal to function pi 2. What is our pi 1? ft. Oh, I'm real sorry. We have to check whether this is a dimensionless group or not. So velocity is m, So velocity is L t minus 1 divide with L omega is t minus 1. So we can cancel out and it will equal to 1, which is dimensionless. Then we substitute into this equation. So our pi 1 is ft over rho d to the power of 4 omega square is a function of v over d omega. V over d omega. Then this is our final answer and proven. So here we already proved this equation. Okay, thank you.